Yeah, in this session, we'll look at the last from the stats part, the usage of the basic stats, right? Where we are talking about right from calculations on the data to making some inferences. That's the scope if we are looking at. Here, I'm making a statement, right? Any statement. Here, in this chapter, the focus is on statements relating to averages are typically means and statements relating to standard deviations. These are the two kinds of statements we will test here, right? Like that, you can, as a statistician, will make statements regarding the relationships between the two variables, statements relating to regression, statements relate everything. Every calculation we do, there is a statistical testing part, right? We have done the calculations regarding the means, standard deviations and all. So there is a statistical testing part. What does the statistical testing part tell you? From the sample, can I interpret it to a population? Whatever the statement that you have made, you will not make it on a sample, you will make it on a population. But using the sample, can I test that? And if I test that, can I accept that statement or should I reject that statement? That's a typical frame of hypothesis testing. So, as a part of this chapter, our focus is on testing for the averages or the means of the data and testing for the standard deviations in the data. Only these two kinds of calculation, but literally every calculation is exposed to a statistical test. Whatever we have done in the statistics chapter, all calculations, whatever we have done, literally they all get exposed to a statistical test. But as far as this chapter scope is concerned, we are looking at only the tests relating to the means and the standard deviations itself. Now, what do we mean by hypothesis testing? As I just now said, we make one statement. That statement, we call it as hypothesis. Right? Someone makes some statement. That statement is called as a hypothesis. And in that hypothesis, we have two types. One is called as the null, the other is called as the alternate. What is the difference here? Any statement we are making, for example, the height of an Indian male is more than 175 centimeters. The average height of an Indian male is more than 175 centimeters. So how am I writing it? Height greater than 175. This is what is the way I can write it. Average height greater than 175. Based on your statement, I am writing it like this. Now, what this hypothesis testing world talks of is, from that statement, you create two statements. One is called as a null hypothesis. One is called as an alternate hypothesis. The null hypothesis should always contain equal to in it. Within the statement, the null hypothesis should always contain equal to, either in isolation or like this, greater than or equal to, less than or equal to. These are all null hypothesis statements, right? In whatever the statement you are making, when I am taking it into creation of the hypothesis to either to test that statement, the way I take it is, one statement I will break it into two statements. You are making a statement, the average height of an Indian male is greater than 175 centimeters. But when I am taking it as a statistician, I'll create two statements out of it. One will contain equality, the other will not contain equality. Now I have to test this. I'm more interested. One of the statements which is made is this. What is the opposite of this? Less than or equal to, I can say. The perfect opposite to it. Perfect opposite to it is less than or equal to. When you are making a statement greater than 175, I mean, if I look at the whole space, if it is not greater than 175, then it could be either less than or equal to 175. So this two put together is all possibilities, right? So what I will do is, because equality should be there in the null, this statement I will call it as my null hypothesis. This statement I will call it as my alternate hypothesis. The null hypothesis in this case is the average height of an Indian male is less than or equal to 175 centimeters. The average height of an Indian male is greater than 175 becomes my alternate hypothesis. Straightforward. Any statement you make, the most of the statements which we are making will have that kind of equality, greater than, less than kind of statements itself. And as far as the scope is concerned, we are talking of those kind of statements only. So probably it is saying the average returns of Infosys is greater than or equal to the average returns of Wipro. So what is the statement here? Infosys greater than or equal to Wipro. What is the opposite side to this? Infosys less than Wipro. The perfect opposite is what we have to take. So which means I can take greater than or equal to as a part of my null hypothesis, less than as a part of alternate hypothesis. So any statement someone is making, the first step for me in the part of hypothesis testing is create a null hypothesis as well as alternate hypothesis. The simple way to create null and hypothesis, null and alternate is like this. The equality should be there as a part of the null. Or if someone is saying the average returns of Infosys equal to 1%. Average daily returns of Infosys is equal to 1%. Which means there is a equal. What is the exact opposite to that? Not equal. It could be less than, it could be greater than. Right? So typically we talk about three pairs. If the null is equal, the alternate will be not equal. If the null is greater than or equal, the alternate will be less than. If the null is less than or equal, the alternate will be greater than. These three combinations will get created for us as a part of any hypothesis testing we do in life. Right? As far as the means and the standard deviations are concerned, any hypothesis testing we do, we talk about only these three kind of relationships. Equal to, greater than or equal to, less than or equal to kind of stuff. And to make things even more simpler, if I am talking of equal to, the alternate is not equal to, right? Which could be less than, greater than. I am talking about on both the sides of my data. So whenever my null is equal to, the test which we will perform, we'll call it as a two-tailed test. We'll discuss a bit more about it slightly later, but simplicity, now that we are in this context, I'm looking at testing on both the tails, lesser than as well as greater than. Both of them are important for me. So that is where we call it as two-tailed test, whereas the other two, we call them as one-tailed test, because we only look at one side. If the null is greater than or equal to, I'm more bothered on my alternate is only one side. Less than is the only thing which is in my alternate. Similarly here, greater than is the only thing. So there is only one side that I have to test for. Whereas if it is equal to, I may have to test out both for less than or greater than, both of them. So that's where we call it as two-tail test for equal to and not equal to pair. And for the other two, we call them as one-tail test. We'll again discuss more about it slightly later. But that is one aspect. So first thing is I need to know what is my null hypothesis, alternate hypothesis. I need to know what is whether I'm doing a two-tail test or a one-tail test. Then state the appropriate test statistic and the probability. So probability distribution, is it a normal distribution? Is it a t distribution? You have to state what distribution it is following, especially if your data is large, sample size is large, you can go with a normal distribution. Sample size less than 30 but still normal, you can go for a t distribution. We have discussed. So I mean, there are so many other variants, but our scope is only up to this, right? There are 30, 40 kind of distributions that are there in the space, but our scope is more to normal and t as of now, right? As far as averages is concerned, our scope is to these two distributions, and we have seen both of them are more or less the same. So we have to specify first of all whether we have to use a normal distribution or a t distribution in this case. We know depending on the sample size and all, we can say whether we are going for z or t. And test statistic is nothing but a formula. For every testing, there is a formula associated. That formula is what we are calling as a test statistic. If you remember, in our mean, we use the sayings the sample value minus the mean by standard deviation, we said, right? That is a test statistic for the means itself. Each value, subtract the mean from it and divide by